Hello, Robert Wohlfahrt here. And in this lesson, I want to show you an easy way to slow down your scripts by simply using the wrong pattern. Or better, the other way around, how to massively speed up your scripts by using the right patterns. For this task, I will use a really simple example to write a script, and I want to implement 3 variants of the script, and I bet you will be surprised by the massive speed differences you will see. So let me start by sharing my screen. In a few seconds, you should see my screen. Here we are. And now let's implement 3 variants of the same script for resolving the same task. The task here, the example task, is to simply take the content of etc passwd, to take every user that is defined on our system, take every user and just print out the username and the corresponding home directory. That is a really simple task. Print out for every defined user the username and its home directory. And let's implement 3 variants of the script. The first variant is the straightforward one. We take all the lines, we read in all the lines, we split the lines, and after that we print out these 2 variables. To avoid working directly with etc passwd, let's create a copy of etc passwd within the current directory. And now let's start with the first script, users1.sh. As always, let's start the script with the shebang line. And now we use the while loop read pattern, while read line do done, to process the content of the passwd file. This while loop read pattern is a really common pattern. The while loop calls the read command for every line from the standard input, and the standard input will be fed by the content of the passwd file. So during each run of the loop, during each run of the comments between the do and the done statement, we have access to the line. Let's, for the first check, only print out the line, read in, and then let's print out the line so that you see that it works. So this is how the script looks like. Let's make it executable. Change mod +x, users1.sh, and now let's run the script, users1.sh, and as you see, we are processing every single line. We are processing the etc passwd file or the passwd file in the current directory line-wise. So now we have, during each run of the while loop, we have within the variable line, we have such a line within the variable line. So, and now we want to process all these lines, and we want to cut these lines. We want to cut these lines, and we want to extract the first part of the line, and we want to extract the 6th field of the line. So we could do this simply with the cut command. So I could use echo $line pipe to the cut command, and the cut command takes -d for the delimiter and -f for the field. Take the line, cut it, add the delimiter colon, and give me the first field. And I don't want to print out the first field. I want to assign the first field to a variable, to the variable username. So I use this pattern, username equals to, and then this pattern within round brackets and a $sign, the command line that produces the output. Yeah, this is a really common pattern to take the output of a command line and write the output of the command line instead this pattern onto the line so that we can assign the output of the command to the variable. So do this a second time now for the home dir. Yeah, we have the home dir and we want to set the home dir to the 6th field. And now let's just print out our 2 fields. Let's just print out username to home dir. Yeah. So this is the really simple and straightforward way to process every line of the file passwd. So let's check if this works as expected. Again, this is how it looks like. And now let's call users1.sh. And as you see, it works really as expected. Yeah, we have in every output line a username and the corresponding home directory. So perfectly. This is the first variant. This is the first variant we could use to process every line from the passwd file. Let's implement a second variant. Copy users1.sh to users2.sh. Now let's edit, modify users2.sh. And now I don't want to use the cut command to split the lines. Now, this time, I want to use a shell pattern to modify the value that a variable gives us. Yeah. So this pattern goes this way, username equals to, and now we can use these patterns with the curly brackets. We take the variable line. This is how the variable line looks like. And now we remove from the right side a string matching a pattern. We remove from the right side everything from the first column. Yeah, we remove from the right side the longest pattern match for colon asterisk. Yeah, asterisk stands for any number, any count of any character. And we remove the longest pattern match from the right side. Yeah, this is the pattern here. So we can use this also for the home directory. For the home directory, we have to take 2 steps. Home dir equals to. The first step is to remove from the line the shortest pattern match from the right side. I want to remove only the last field, the shortest pattern match for colon asterisk. And then the home dir variable now contains all these parts, yeah, but the last one. And now I want to remove the first parts until the home directory. And I do this with a second step. Yeah, I remove from the now current content of home dir. I remove from the left side. From the left side, I now remove everything, the longest pattern match for asterisk colon. Yeah, so this is the second step, home dir equals to. And this works. This works perfectly. Let me show you that this works. Yeah. Again, this is how it looks like. Yeah, we remove from the right side everything, starting with the first colon, and then by home dir we remove the last one the last field, the shortest pattern match, and then the longest pattern match from the left side. And let's try this out. Perfectly, it works. Yeah, it works perfectly. So now we have two variants. We have two variants for processing the content of passwd. Users 1.sh and users 2.sh. And with a different implementation here. And now let's measure the performance of these two variants. We have a passwd file, and this passwd file has 26. It has 26 lines. Let's create a larger file, a larger data set, to show you the really huge differences we have here. Let's generate a passwd file that is 100 times the original passwd file. For I in seq100 do cat etc passwd and append the content to the new created passwd file. Do done. Let's first remove the passwd file, and now again. So now we have a passwd file 100 times the original one. Yeah, we have here 2,600 lines within the passwd file. And now let's measure the performance. By the way, we are using here a lot of tools. Yeah. If you need to know more, or if you want to know more about such tools, I don't know if you know, perhaps you know it already. I have written the Sharescriptus Toolbox, a free PDF that gives you a load of these command line tools. Here I collected the most command line tools I used within my last 15 plus years of shell scripting or working at the command line. And you can get this free PDF at shelltoolbox.com. Yeah, this is the website, shelltoolbox.com. Go to there and get your free PDF, the free Sharescriptus Toolbox. Yeah, but back here to our two scripts, we want to measure the performance differences. First, we measure with the help of the time command how long it takes for the user's 1.sh script to process these 2,600 lines. Yeah, I don't want to see any output from the user's 1.sh script, so I throw away the output by redirecting it to dev null. So, and now let's measure the time it takes to process these 2,600 lines. Yeah. Okay. What you see is we have a real time of 5.4 seconds. 5.4 seconds. Let's time this as second time. Yeah, to prove the time perfectly, 5.3 now. Okay, perfectly. This is the performance, or this is the time it takes for the first script. Now, let's measure the time for users 2.sh. Wow. A second time, again, wow. Yeah, not 5.3, we have 0.1 seconds. Yeah, more than 50 times faster. Yeah, we need much less time. Why? Why the hell is the second one so much faster? Yeah, and the answer here is users 1.sh, users 2.sh. If we compare the number of processes that needs to be started for processing these lines, yeah, then we see here for every line within the passwd file, we need to start one process. The first one is the read process. Then we need to start the echo and the cut processes number 2 and 3, and then 4 and 5. For every line here, we have to start 5 processes. And the starting of a process is a really, really expensive task for a system. Yeah. In the second variant, we need only one single process for each line. One single process, the read process, and these patterns for assigning, removing values, patterns from a value of a variable, these patterns or these assignments are done directly within the shell, within the script or within the shell that runs the script. We don't need to start any more external processes. Yeah, the starting of external processes is really, really expensive. So let me show you a third variant to speed it even more up. Yeah. We could take the command cut directly. We could take the command cut directly to process data from, for instance, etc passwd. Yeah, we could take the cut command to say, take the delimiter colon and give me the field number 1 and the field number 6. Give me field number 1 and field number 6. Yeah, voila, that works. And now let's give an other delimiter within the output. I give now as the output delimiter a simple space. Yeah. Now you see we have the username, then we have the space, and then we have the home directory. And now let's write a script that uses this pattern. Yeah. So let's copy uses 2.sh to uses 3.sh. Let's edit. Let's modify uses 3.sh. And now we do the following. We call the cut command. Sorry. Yeah. We call the cut command, and we pipe the output of the cut command to the while read loop. So we call the cut command with the passwd file as input. We read this in with the while loop. I remove here the passwd file at the end of the loop. And now comes a little trick. I can call the read command with more than one single variable. I can call the read command with 2 variables, for instance, and the read command will read in one single line per call, and then the read command will split every line itself. And for splitting the lines, the read command will take per default the IFS, the internal field separator, and the internal field separator contains also a space. So we can, with our data here, call the read command really simple that way. Please read in the home dir and as the first variable, the username. So, and now we have to do nothing more between the do and the done statement. Yeah, read reads in every line, splits the line into 2 variables, and we have direct access to these 2 variables within our while loop. Let's prove that it works. Yeah, let's call users3.sh, but let's print out only the first 26 lines from the second, from the run, yeah, from the passwd file. As you see, we have the home directory and the username. This is how it looks like. Cat uses free.sh. Again, this is how the first variant looks like. This is how the second variant looks like. And now this is how the third variant looks like. The third variant uses here only the cat command. Now let's time all these three variants. Let's time here we are, the first variant. Again, we need 4.3 seconds this time. Let's time the second variant, 0.1 seconds. And let's time the third variant. Wow, again, a huge difference. 0.07, 0.08 seconds we need here. So take this as the result from this lesson. The starting of processes is a really, really expensive task for the shell. So try to avoid this. Try to use other patterns to extract data, to work with data. Try to avoid using many processes within your script if you want to speed up your scripts. So I hope you enjoyed this lesson. If you enjoyed this lesson, let me know just in the comments or like this video. And as a reminder, shelltoolbox.com for the Sharescriptus Toolbox, the free PDF. Okay, see you next time.